Hi, welcome to our last Team Teach. And this Team Teach, we are going to go over our last set of problems. We will have 18 problems this time. So let's get it started with our first one. Okay, Demia, what is the Y and X axis?
Okay, I'm so glad you asked that. So when you have a grid here, you have, so for an example, at the very top, you have your title, which is gas on a road trip. You have your miles on bottom and your gallons of gas to the left. If you look at this bottom here, this horizontal line with your miles, that is what you refer to as the x-axis. Gallons of gas, which is up here, up and down, vertically is your y-axis. So if you look at this particular chart, you'll see the line right here, and it's showing that you are at the tip top of your gas, and as you continue to drive with your miles, the gallons of gas go down. But once you stop at this point, it's kind of like you're filling up. So you fill back up, you're still at the same point, but your gas goes up, and again, your gas is going down as you continue to drive your miles across country. Can you tell me how does a function machine work?
Yes, absolutely. So here we have it telling us that our X is going to equal 0, 1, 2, and 3. So our rule here is to multiply by 3 and add 8. So our input again is 0, 1, 2, and 3. And whenever we put it in to do our rule right here, multiply by 3 and add 8, on the right side, this is what we're going to get. So 0 times 3 plus 8 is 8. 1 times 3 plus 8 is 11. 2 times 3 is 6 plus 8 is 14. And 3 times 3 is 9 plus 8 is 17. Now, whenever we want to add a little bit more to it, we're going to add the g of f of x. And then we're going to substitute x with our numbers right here. So our first one is going to be g of f of 0. And then we're going to do 3 times 0 is 0 plus 8 gives us 8. And then our next one we have right here, and we're going to put 1 in for x. So 3 times 1 is 3 plus 8 is 11. And it shows right here what we got earlier. And then our last two, and it just shows us step by step how to do it. We're going to have 3 times 2 is 6 plus 8 is 14. And then when we substitute 3 in, we get 17 for our answer. And then if we want to put it in a little slide here, or a table, that's what it would look like. All right, Taylor, how can we determine the slope of a line segment determined by these given pairs of points?
That's a great question, Sarah. Thanks for asking. So our given pair of points is we have point P, which is on 3, 1, and point Q, which is on 5, 5. And so when we're looking at these, first off, we're going to go ahead and label them X1 and Y1 and X2 and Y2. This is going to help us when we're plugging these numbers into our formula later on. Here's our formula. It is y2 minus y1 over x2 minus x1. And now we're going to plug in our points into our formula. So we have y2 minus y1 is 5 minus 1, and x2 minus x1, which is 5 minus 3. Simplifying this is we have 5 minus 1 is 4, and 5 minus 3 is 2, so we get 4 over 2. And then 4 over 2 can be simplified into 2. So that means that the slope of these 2 points is 2, or 2 over 1. That means that our line is moving up the graph 2 points and over to the right 1 point. This can be seen here in our graph. We have point P here and point Q. And here's our line segment. And here we can see the slope that goes up 2 and over 1. Courtney, how do we get an equation into y equals mx plus b if it is all mixed up?
That's a good question. So we see here right at the top that we have this equation, 2y plus 9x minus 5 equals 0. And we're given the point S, which is 0, 3. And we're wanting to get it into y equals mx plus b. So what we're going to do is we're just going to take this equation and we're going to solve for y. So we're going to subtract 5 from both sides, subtract 9x, and then divide it by 2. So that gives us y equals negative 9 over 2x plus 5 over 2. And that's what gets us into the y equals mx plus b. And this equation right here we can see is graphed with this green line over here on our graph. And now we want to be able to graph the point 0, 3. And to do that, we're going to use the equation y minus y1 equals m times x minus x1. So we plug in our y from this equation, which is y, and then minus y1 is negative, or it'd be negative 3 because we're subtracting y from y1, and that's this y. And now we have 2 over 9 as our m, which is our negative reciprocal. So we're going to take this slope of this line and we're going to pretty much just flip it over. We're going to do 2 over 9 instead of 9 over 2, and then we're going to take the opposite sign. And then we're going to do x minus x1, so we're going to take the x from our point and plug it in. And then when we solve it to get it to the y equals mx plus b equation, we're going to subtract 3 from both sides. So our new line would be y equals 2 over 9x plus 3, and that would give us our line, our purple line right here that is perpendicular to this green one, meaning it only intersects in one spot. Demia, how do I find the measurements of a concave polygon?
Okay, that's a great question. If you look here to the right, we have what is called a concave polygon, and this particular one has 8 different sides. Okay, so you start by, you count the sides, now as I said, it's 8. So with this particular formula, you're going to do n minus 2, n being the number 8 times 180. So you're going to plug in 8. You're going to get 8 minus 2, which is 6, and you're going to times that by 180, and that's going to get you 1,080 degrees. But we're not quite done. On to step number 2. So if you look here inside this particular polygon, you have different measurements, and you're going to add all of those measurements. Since they're all y, you combine them all together, you're going to end up with 54y. So when you have that, you're going to divide 54 by both sides to get rid of the 54. So once you divide 1,080 by 54, you're going to get y equals 20. And then for our final step, you're going to plug in 3y equals 3 times 20, which equals 60 degrees. And then you're going to get 7y equals 7 times 20, which equals 140 degrees. And then 12y equals 240 degrees. So that's how you find the measurement of a concave polygon. Courtney, how do I make this figure fit inside a cube?
That's a good question. So this figure right here, if we look at it, it has a triangular base, and then all the sides are also triangular. So we have a base over here, and then we have a triangle side this way and a triangle side this way, and then another one with this big triangle in the back. And what we're wanting to do is make it fit inside this cube, but we don't want any of the faces, which is each side, touching any of the faces on this cube. So when we move it over, we see that the point to this triangular figure is touching point E, point B, G, and D, and all of our sides all of the faces are not touching a face. We have the lines or the verticals of this figure up against the face of the cube, but our faces itself are not flat against it. Sarah, what is the measurement of angle 1 through 12 on this?
All right, so before we can answer that, we need to go over a few vocab words. So something that we need to know is that supplementary angles have the sum of 180 degrees. Congruent angles have the same measurements, and vertical angles are two non-adjacent angles that are formed by two intersecting lines. So knowing that, we can get started. So our first angle here, number 2, we know it's 63 degrees. Because look right here, this is given and it tells us it's 63 degrees. So these two are congruent, so we know that this is going to be 63. Now remember, everything above this line must add up to 180 degrees. So how do we find that? So number 3, and I'll show you in a minute how we know it's 61 degrees for sure. We can add it up, or you can look right down here. We have 61 degrees here, so we know that this is going to be 61 degrees. And right here, we have 61 plus 63 is 124. When we subtract that from 180, we get 56 degrees. So now we know that 5 right here is 56 degrees. Knowing that that is 56 degrees, we know that angle 1 is 56 degrees. Now knowing that angle 3 is 61, we know that angle 4 is 61 degrees. So you can kind of see a pattern here as we're doing this top half of how to solve the angles. So we notice right here, if this is 61, angle 9 is going to be 61. And to get the difference from that, we're going to subtract 61 from 180 to get 119. If angle 6 is 119, angle 10 will be 119. All right, so now we have 7, 8, 11, and 12 left. So angle 12 will be 56 degrees, and angle 7 is 56 degrees, because remember, they're corresponding angles, so they're going to have the same measurements. To find what's left, we're going to take 56, subtract it from 180, to get 124. So angles 11 and 8 will be 124 degrees. And that should be all of it. Oh, and also a neat little tidbit is here in the center, if we add up all of these, we're also going to get 180 degrees. All right. Taylor, how can we find the measures of the interior, exterior, and central angles of this shape?
Thanks for asking, Sarah. It's important to know the difference between the interior, exterior, and central angles in order to be able to find their measurements. First, we're going to look at the interior angle. We're going to use our interior angle formula, which is n minus 2 times 180. And this is going to give us the sum of the interior angles of our shape. Right here is n is going to be equal to the number of sides in our formulas for these. And right here is our interior angle that we're looking for. So we know that because n is equal to the number of sides, we're going to plug in 9 for n. When we plug in 9, we get 9 minus 2 times 180 equals 1,260 degrees. Because this is the sum of the interior angles, we need to now divide this number by the number of sides so that we know the measurement of each interior angle. When we divide 1,260 by 9, we get 140 degrees, meaning that each one of our interior angles equals 140 degrees. Moving on, we're going to look at the exterior angle next. To find the exterior angle, we are going to take 180 and subtract the measurement of the interior angle. The interior angle and the exterior angle form supplementary angles, meaning that they add up to 180 degrees. So because we know the measurement of the interior angle, we can pretty easily find the measurement of the exterior angle. Right here's the exterior angle, and we are going to take 180, subtract 140, and then we get 40 degrees as the measurement for our exterior angles. And lastly, we're going to look at the central angles. And the central angle formula is 360 degrees divided by n, where n is the number of sides. So we're going to take 360, that's our central angle. We're going to take 360, divide it by 9, and we get 40 degrees. So that means that our central angle is also 40 degrees. Courtney, how do I find the angles to this triangle?
That is a good question. So we are going to start with angle 1, and we see that this is one big giant triangle. And we know, as Sarah told us earlier, that the area or the angles of a triangle all add up to be 180 degrees. So we're going to add 74 plus 26 together, and we're going to subtract it from 180, which equals 100. 74 plus 26 is 100, and when we subtract it from 180, that gives us the angle, or the degree, 80 degrees for angle 1. Now we're going to move next to angle 4. And so we know that angle 4 is congruent to this angle right over here. And so we know that angle 4 is going to be 26 degrees as well. And now we're going to move on to angle 3. And since we already have the measurement for angle 4, and this one is given to us, we see that this is a tinier triangle, and we're going to add them all together and subtract it from 180. So angle 3 would also be 80 degrees. Another way to find that out is angle 3 and angle 1 are congruent to each other also, so they'll also be the same degree also. Now with angle 6, we see that angle 6 is congruent to this angle over here. So we know angle 6 is going to be 74 degrees. Angle 1 is also congruent to our angle 5. So angle 5 will also be 80 degrees. And angle 1 and angle 8 are also congruent. So angle 8 will also be 80 degrees. Now, angle 7, we know that the angles on a straight line equal up to 180 degrees. So angle 8 and 7 will add together to get 180. And since we know that angle 8 is already 180 degrees, we'll subtract that from angle 7, and angle 7 will be 100 degrees. Now we're going to do the same with angle 2. Angle 2 is also congruent to angle 7, so that will make 100, but we can also subtract it from angle 3 to get 100 degrees as well. Demia, how do I find the area of the region between the circles?
Okay, so let's say we have 2 circles. So when we have these 2 circles, we have one circle being 100 and the other one being 30. So we're trying to find the difference between the two. So you subtract those, and you're going to end up with 70. So in this particular one is 70, and that is the difference between the 2 circles, the area of the region. Okay, Sarah, what is the area and perimeter of this triangle?
Okay, so remember first before we start, area is going to be 1/2 times base times height, and perimeter is the measurement all around the object. So here we have a triangle, so we're going to add all sides together. So to find the area, let's start with that first. We're going to do 1/2 times base times height. So we're going to do 1/2 times 6.2 times 2.6. And why we're doing 2.6 is because that is the height of our triangle. So whenever we do the math, we're going to get 8.06 centimeters squared. And anytime that you're doing area, whatever unit of measurement you have will be squared. So knowing that, the perimeter is different because you do not square your unit of measurement. It's just going to be whatever measurement it is. So our perimeter is 8.5 plus 6.2 plus 3.1, which gives us 17.8 centimeters. All right, and on to our next question. Demia, how do you find the perimeter?
Okay, so when you're finding the perimeter, you are basically adding up all the sides. So for an example, so you're going to do A plus B plus C to find the perimeter. So right here we have this triangle, and it doesn't really matter what you consider your A, your B, or your C, as long as they're all labeled something different. So in this particular one, we're going to use our 48 as our A, our 69 as our B, and our 82.3 meters as our C. and you're going to end up with 139.3 meters. And like you said before, you don't square this when you're doing perimeter. It's just whichever units you're using. On to our next question. Taylor, could you tell me, with this empty pail overflow, if we were to add one of each of the following measurements?
Yes, I can. So when we're looking at these measurements, we see that we have 1 gallon, 1 bottle, 1 quart, 1 pint, 1 gill, 1 jack, and 1 mouthful. When we're looking at these, we look at the ones on the left, and we might not recognize them as much as we do as the measurements on the right. That's why it's important to know the relationship between these. These measurements increase on a doubling scale, and that means that each one is going to increase by one of itself. It's going to, and then when you're going down, it's going to decrease by half of itself. And so when we're looking at this pail, we can start with the gallon. And the gallon is going to fill up half of our pail, and that leaves about a gallon of space left. And so going by the rule of halves, we can add a bottle, and that's going to take up half of our space. And there's our bottle, and then we add a quart, followed by 1 pint, followed by a gill, and then a jack, and then finally a mouthful. When all of these pop up, we will be able to see that we just have enough room. This little space up here, we are adding 1 mouthful, and so this leaves room for just 1 mouthful remaining in our pail. So no, it would not overflow. Sarah, why is angle QVP a right angle?
All right. So again, we need to make sure that we know that a straight line equals 180 degrees. And we see a line here where it's labeled P. It is going to intersect our line. So we know that whatever measurement that QVP and SVP, whatever they are, they're going to add up to 180 degrees. So whenever we have a line that intersects a straight line, you know that it's going to be 90 degrees. So our angle here for QVP will be 90 degrees. But if you wanted to find SVP, it would also be 90 degrees. Because like I said, the straight line here, we have to have our two angles add up to be 180 degrees. All right, Courtney, what is the area of the bigger circle?
That is a good question. We have a square and we have a big circle that is surrounding this square. And then we know we can find the area of a circle using, sorry. How do I get rid of this, guys? Oh my goodness. Can anybody else get this off the screen?
Okay, I just took control. Okay. Is it still showing on yours?
Where it says a gift from Zoom?
It's not showing on mine anymore.
Okay, let me see.
Okay, so how you just want to, we can cut this part out of the video, I think.
Let me move backwards here. Sorry about that, guys. Okay, so we're going to start this slide over. So what we have is a square and a bigger circle surrounding this square. Now, we don't have the measurements for the square or our circle, but we do know that to find the area of a circle, we use the equation pi r squared. And here we're given the measurements for these two sides, and we're going to use the Pythagorean theorem to find this line right here, which is about the radius of our circle. So we see that both sides are equal to 5 units, and we are going to plug it into a squared plus b squared equals c squared. So we'll have 5 squared plus 5 squared equals c squared. And so our radius will be equal to 50 equals c squared, which is the radius. And then we'll plug that back into our equation for pi r squared to find the area of our big circle. So it would be pi 50 squared. And when we put that into a scientific calculator, it will come out to 7,853.98 units squared. And it'll be units squared because we're wanting the area of the circle. Taylor, what type of motion was made to transform the figure on the left into the figure on the right? What would it look like if we reflected the shape over a horizontal line?
That's a really great question, Courtney. So it's important to know the difference between the types of rigid motion when we're talking about translating shapes. When we look at these two shapes, we want to know how we got the shape to the left into the shape on the right. We can tell that the triangles on the shape on the left are facing right, whereas the triangles on the shape on the left are facing the left. This means that there's no way that we could have reflected this shape in one movement for these triangles to be on the bottom as well as facing the left. This means that we performed a rotational rigid motion on this shape. We did this by holding on to this shape right about here and turning it clockwise about 180 degrees, and that looked like this. And it's called a rotational rigid motion, and it looks like this. And so now we're going to look at what it would look like if we reflected the shape over a horizontal line. And so we're going to place the horizontal line right here in the center, right through the square. And we want to reflect the shape over the line. This means the triangles are going to go to the bottom and the trapezoid is going to go to the top. The difference between this and the rotational rigid motion that we saw is that the triangles are still facing the right because it wasn't rotated at all. Demia, how can I make a vertex figure?
All right, that is a great question. So when you are attempting to make a vertex figure, you have to make the degrees equal 360. So you will need 3 different shapes. So the shapes that we're going to use today are a hexagon, a dodecagon, and also a square. And for a little mental note, the hexagon has 6 sides, the dodecagon has 12, and the square has 4. So if you plug in your formula, you'll know that you're going to add 90 plus 150 plus 120, and it's going to get you 360. And that is how you make a vertex figure. You just need 3 sides that add up to be 360 degrees. Courtney, can you tell me if these figures have rotational symmetry?
I sure can. So rotational symmetry, we know, is if we took this diamond or rhombus right here and we grabbed it by this point and turned it 180 degrees to where the point was up here. We want to know rotational symmetry is this figure would look exactly the same as it does now if it does have rotational symmetry. So if we took this rhombus and we turned it, it would look exactly the same. So we know that this figure right here does have rotational symmetry. Now if we take this triangle and we grab it by the point right here and we turn it 180 degrees to bring it down to the bottom, it will not have rotational symmetry because the figure at the end of the turn will not look the same as the beginning. Now we are going to use this hexagon and we are going to grab it from the center of this line and turn it 180 degrees And when we get done turning it, it will look exactly the same. So we know that this hexagon and a rhombus have rotational symmetry, but this triangle does not, because when you turn the triangle, it looks different afterwards than it did from the beginning. That is the end. Thank you guys for watching.